title of the talk is Beyond JUnit, Pragmatic Ways to Increase Code Quality. And I want to talk to you about what do I mean by pragmatic before we get too far into the talk. Now, if you just type pragmatic into Google, you'll get this definition, which is dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. So when I present things to you today, they're largely going to be pragmatic in that sense that you as an individual developer can go and do these things without a lot of ceremony, without a lot of buy-in from other people. I like tests for that reason, that I can kind of play a little bit more with those than I could with mainline code. And during this talk, I'm making a couple of assumptions about you. I'm assuming you already do some kind of unit testing with JUnit, with some kind of modern thing, maybe JUnit 5, that you understand the basics of unit testing and why you would do that and how you would do that with JUnit 4 or 5 or something like that. And that you've already covered the basics at your workplace or at home or whatever with static analysis tools or enforced code styles, things like that. I'm not really going to talk about those things today. So I'm assuming you've kind of already covered those things. And so you'll see two things in this talk, and if that doesn't interest you, that's totally cool. You're going to see how to test the architecture of your code within tests, and then you're going to see how to make your code play well with others. And then two things to keep in mind before we get moving. I love this quote by Martin Fowler. I don't generally think it's a great speaking tip to go and call your audience fools. So basically, write code that humans can understand. We're writing code more for each other than for the machine itself. So try to keep that in mind. I try to keep that in mind when I write code. I try to keep that in mind when I'm bringing in code to use that other people have written. And then the other thing, I think this is fascinating that this was said in 1969 at a NATO software conference in Rome. Testing shows the presence, not the absence of bugs. So even though these things will bring you confidence, they're not going to prove that your code is bug-free. They're just going to prove that they're not where you're actually testing for them not to be, okay? So the first thing we're going to go over is architectural testing. So what's the problem? We've got this beautiful green field. We can do anything we want with this architecture for this application that we're going to build. And let's suppose it's just some standard 3-layer architecture. We've got an API layer, we've got a service layer that has the services in it, and we've got the data layer whose responsibility is talking to a data store of some kind, like a Postgres or a Redis or whatever else. And inside those, it kind of looks like this. In the API layer, you've got some controllers, and in the service layer, you've got some services, and in the data layer, you've got repositories. And you want this data to flow in this direction from left to right. You want controllers talking to services and services talking to repositories, and you really don't want it going the other way, and you don't want random lines all over the place. So you've built this application. It's your nice greenfield application. It's pristine and beautiful, and you've done such a great job. And now they've assigned some people to work on your project while you go on vacation. How do you keep this from degrading into something you don't want? Because somebody's going to do this, right? Somebody's just going to say, I need an entity in the controller layer. I'm just going to wire up the repository because Spring will let me do it. Or, there's a convenient method in that controller. I'm going to let this service talk to that controller, and Spring will let me do it. We're good. And then somebody's just going to do something like this, and that just doesn't make any sense in any world at all. But how do you prevent this? Well, maybe your organization has got a Word doc that's been handed around. When your first day, you get emailed the Word doc, and nobody reads it, and nobody thinks about it, and everybody's got slightly different varying versions of the corporate standard, right? This is how you can tell I work at a big company. Maybe you got a wiki. Let's put it in a wiki instead. That's more accessible. Anybody can kind of edit it. It's got an edit history. We'll know what's going on. But the problem is, this was made 10 years ago. And we have this grandiose notion of I'm going to make it happen. And then we edit it, and nobody updates it. And then the person who invariably gets frustrated with that state of being and just, leaves the company. And then the wiki just dies. So I got it. No, we'll put it in a README. We'll put all these rules in a README and the application that we've got here, and we'll definitely keep this up to date after we ship it, maybe, right? And the problem is, there's nothing really to actually enforce any of those things, right? Even if I did write it down, even if I did keep it up to date, there's no way to actually enforce those rules. So what do I want these rules to be enforced automatically. I want them to be accessible. I want people to understand what those are and why we're using them. And I want it to be really fast. I don't want to have to spend 6 years going through static analysis and shipping it off to some team to look at or anything like that. I just want to get it done quickly. So ArchUnit is going to save us, okay? Adding ArchUnit to a project is really simple. You have one line of, if you're in Gradle, you have one dependency. In Maven, you have another couple of lines of dependency. In the test scope, it's just this one dependency you add. And let's write a simple, really simple architecture test. Now, one of my pet peeves as a developer is I don't like impl. If you have an interface and you have an implementation of that interface, I just, for whatever reason, don't like having impl at the end. So I want to write a rule against that. Now, this is maybe not the best architectural rule, but I'm just showing you how the library works before we get into more complicated examples. So we'll have a test. We'll call it impl naming rule. And there's 3 parts to the test, right? Any good unit test has got 3 parts. There's like a given when then or a range act assert, something like that. These tests kind of work the same way. There's the given part here. Which classes are we talking about? So in our architecture of classes, the array of classes that we have in our application, which ones do we really mean to apply these rules to? There's the rule itself. We'll get into what that means in a second. And then there's the assertion that these classes pass this rule, okay? So to get the classes, we just do a class file importer, and we import whatever packages we want. And we can import more than one package if we want to import 1 or 2 packages here. That's any number. And I should point out that all the sub-packages for, so donut API.services, those will be imported as well. So now that we have the classes that we care about, we can define our rule. So our rule is going to say, no classes should have a name matching impl. Now that's just a regular expression that says anything that ends in dot, or anything that ends in impl. I don't want that. And so this rule, we'll just simplify it on the screen a little bit. Looks like this. And if we run it, we'll get this output from JUnit. These are all run within JUnit. It's a simple test. We'll run this. It'll run in a couple of seconds, not even. And we'll get a clear indication that this is an architecture violation. And we'll get a clear indication where that architecture violation happened. So this is in some service impl. It matches star.impl, right? And I don't want that. Now, it also has this description that is made from the rule. I didn't have to do anything to make that description. ArchUnit pieces that together from the conditions that I've given in that rule. Now that's great, but it doesn't tell me why I needed to have that rule. So I can put this because on the rule, and I do this for all my rules so that people who come after me know why I am enforcing this rule. Now this isn't a great, again, this is just an example rule to show you how the library works at a high level. So this isn't the most descriptive because, but it's there for that. So when you run it again, you'll see no classes should have name matching impl because it doesn't tell us anything useful, okay? Let's simplify this a little bit on the screen. I know this looks more complicated, but I swear to you it's more simple when we get through it. So instead of having the test that we showed before with loading the classes manually and then defining the rule and then applying the rule to the classes, we can use JUnit 5 extensions to give us some shortcuts. So the first thing to notice here is we have this analyze classes annotation. That's from ArchUnit. And we say which packages. So before, when I showed you those packages that we want to import, this is the same thing. I'm also using some import options here to say don't include any of the test classes because I don't care to enforce the rules on the test classes. And I can also say don't load things in jars. There's a couple of other import options that I've never actually used. And then each test that we want is a static final arc rule annotated with archtest. So we don't have to go through the ceremony of loading classes and creating a rule and applying the rule. The loading of the classes and the applying of the rule are all done by the framework as long as I have these archtests here. So to simplify, showing you these from now on, when I show you these rules, we're just going to show them like this. And because a lot of this is boilerplate, we'll just have them like this. So you can apply the rest of this for the rest of this section of the talk, okay? So let's say we want to prohibit the use of a dependency in our application entirely. In this case, I'm going to pick on log4j. So no classes should depend on classes that reside in any package, and these are the two log4j 1 and 2 packages that I don't want to continue using anymore. Now I like this because this is just plain English. I can read this and I know what I'm getting. I know what I'm enforcing. And if I put a because on there, I know why I'm enforcing it. So we run this and we get this pretty long description. Now again, because ArchUnit is piecing that description together for me, these can get pretty long. If you get a complicated rule, these descriptions can get pretty verbose. And that's not always what we want. We want them to be simple. So we can go in here and we can put as. So we can say anything above this point in the rule, don't come up with a fancy name for it. Just use this thing here. So when we run it again, we get stop using log4j because our standard is logback. Now this is a real example. I actually wrote one of these at work because of the whole log4shell thing. And so we use this at work to find places in our architecture where we were violating this and fixed it. So now we've got these rules. You have the basic idea of what we're talking about. Let's talk about the parts of the rule. So the first part, classes, these are the things we're talking about, right? So there's classes, you can talk about methods, and you can talk about fields. The next part is the predicate. So which classes do we care about? So you could say all the classes in the architecture or in the project, but in this case, I only want ones that are annotated with controller or are annotated with REST controller. If you know what meta annotations are and you know how these two classes are put together, I could just say are meta annotated with controller, but I like this because it shows an or in there, and these rules can get pretty complicated if you want. So there's a lot of predicates. Now I just copied and pasted this out of the documentation, but there's a lot of them, and what I want you to look at here as I page through them is you can see there's positive and negative, right? So you don't have a not operator. You have explicit predicates that are annotated, are not annotated with, right? There's lots and lots of them. There's pretty much anything you can think of that you would want to do with a class to select it built into ArchUnit. And if you don't, you can write them yourselves. Writing a predicate is not that hard. I'm not going to show it in here because it does take a little bit of time, but it's implementing an interface and it's pretty straightforward. The next part of the rule is the condition. So the rule itself, what am I prohibiting or allowing? So it should reside in a package with controller in its name. Now this ... at the end is the shortcut for, AntPath shortcut for has controller in its name. There's all sorts of conditions as you might expect. There's also, again, positive and negative conditions in here. There's pretty much anything you can think of that you would want to do with a condition on a class, you can do it in here. And it gets pretty complicated, like transitively depend on classes. That is a fairly complicated concept if you think about it, and you don't have to go off and figure that out. ArchUnit rules have figured that out already for you. And because you have these positive and negative aspects to this, I can write this rule in two ways. So I can say classes that are annotated with these two annotations should reside in a package controller, or I can flip it. I can say no classes that are annotated with these should reside outside a package controller. Okay? So it just depends on how you feel you better express that rule to yourself and to your coworkers or whatever. This is a great way to, I think this is a really nice flexible thing that rules don't always have to be written in from a single person's point of view. And as I said before, you can write rules for methods. So any methods that are declared in classes that have name matching util should be static. So I don't want to have a util class with instance methods in there. I want them all to be static. Or fields, there's not that much you can say about fields, but I want to say that any fields that are static should also be final. And again, you can do naming. There's different predicates and conditions for methods and fields. I'm not going to go into super amount of detail on those two. So let's go back to our architecture, right? We've got this thing that started off this whole conversation is we want to enforce this architecture. Now, we could do it the hard way. We could say, we could write a laborious amount of rules that enforce this architecture, and that's a perfectly acceptable way to do it. So we'd say no classes that reside outside of package controller should access any classes that reside in any package controller. So nothing can talk to controller. And the only thing that can talk to service is controller. It's a bug, like an actual bug. So classes that reside in any package with service in its name should only be accessible by packages and controllers. So that prohibits, in this case, services from talking to one another. So you'd probably want to put in a condition for that. And it prevents data stores from talking to services. Great. Now you could go through and you could write all these rules and you could do all this, and that's a perfectly acceptable way to do it. But there's some syntax sugar in here that ArchUnit provides for you to give you this for free or for very little work. So I can just say a layered architecture, and I can define my layers. So I'm saying I've got a controller layer, it's defined by these packages, a service layer defined by some other packages, and a data layer defined by some other packages. And then I give the conditions. I'm like, what am I preventing them from doing, or what am I allowing them to do? So I'm saying controller may not be accessed by any other layer. Service may only be accessed by layers, by the controller layer. And then data can only be accessed by the service layer. Now this enforces that picture that we had at the beginning with one rule. I don't have to go and write 15 rules. I don't have to. You can put exceptions in here. I'm just not showing it because it would be more verbose. It wouldn't fit on the slide very well. But you can put exceptions in there. You can define these however you want. And again, you can define other rules to allow them if you wanted to. So I think this is nice because you can define your whole architecture with one rule. And it gets more complicated. I'm just not showing you all the examples in the interest of time. Anybody use Onion architecture here? I don't. A couple people, cool. You can also define them for Onion architecture. You can see here my domain models, services, and applications, and then here's the adapters. I don't use Onion architecture, but this is what happens underneath the covers is ArchUnit is writing rules like I showed you before. This is just syntax sugar on top of ArchUnit writing more rules for us. One of the neat things I like about that is available in ArchUnit is, has anybody used PlantUML to diagram your architecture? Okay, a couple of people. I love PlantUML because you can put it into your READMEs and then they have a nice architecture diagram. It's this rather terse syntax. I'm not going to go through it, but this is kind of what it looks like. It's all text-based. And when you run PlantUML text like this through the PlantUML renderer, you get a fancy diagram like this. Okay, so it's nice because you can, if your renderer like a Bitbucket or GitHub or whatever supports rendering PlantUML, you get a nice text base for definition of a nice picture here for your architecture. Now I can enforce that architecture. So I have a PlantUML, my project.plantUML file, and I say, go get me a URL to that file. And then classes should adhere to a PlantUML diagram, my diagram considering all dependencies. Now considering all dependencies lets me limit transitive dependencies or test classes or just focus on certain parts of that PlantUML diagram. I'm not going to get into that part. But I think this is pretty cool because now it ties that README we talked about. I can say, use this diagram in two places. I can show it to you when you open up the project and look at it, and I can enforce that with the code itself. There's a few rules that ArchUnit provides for you. You don't have to write some of the more obvious rules that you'd want to have. So not allowing the standard streams to be manipulated. So don't use system out, system in, or print stack trace. Don't throw these generic exceptions because that's generally considered either a bad idea or a bad form. Don't use built-in logging for whatever reason. Don't use Joda time because there's Java 8 introduced a superior alternative to that. Prevent field level auto wiring. I love this one. So it prevents you from doing that. Really simple to use these. These are all built in. So I would say in this case, no classes should access standard streams. And then I have that first rule that I showed you. I can't use system out, system in, or print stack trace. Because again, those are generally a bad idea to start using. Or it's not a bad idea, it's just there are better alternatives to that. So ArchUnit works great for these greenfield projects, but what about a legacy application? Like, what about this application at your business that's 20 years old, that's making you a ton of money, that 1,500 people have been through, that you want to bring towards the light? You want to have an architectural rule, but you know it's not going to pass. You know, if I define any one of these rules that I showed you, there is some part of this application that will fail. So how do I do that? Let's go back to our layered architecture. This is the same rule I showed you before. And what I can do is I can say this is frozen. So what does that mean? Well, first of all, I go into ArchUnit properties and I turn this concept on. I say, allow freezing rules. And then I'd run all my tests. I define the rule that I think is going to break, and I run the tests, and it'll pass. The first time through, this test will always pass, even though it probably shouldn't, right? And what happens is, ArchUnit will crank out a bunch of files for me. It'll give me a store.rules file, which tells me all of the rules that are frozen, and it'll give me a UUID named file for every rule that has failed, right? And so I check all this into my repo, and the next time through, when I run these tests, if I have the same set of failures, it'll let them slide. It'll say, okay, well, we know that this class here fails this, but we've noted down the fact that we don't care that this fails for now. Now, if I come through and I write another failure, I write a new class and I have a new failure for this rule, and I run the test, it'll fail. That test will fail because it'll say, hey, this new thing that is failing is not in the frozen list of exceptions. Contra to that, if I go through and clean something up, so if I find one of these frozen rules that, or these examples that I've frozen before, and I say, well, I fixed this, so now I've got one less thing that is violating the rule, that test will pass, and these two files will get rejiggered. So it'll delete one of the UUID named files, and it'll update the stored rules file, and I can check those in. And so now I have fewer and fewer and fewer violations to that rule. So this is a great way to move that legacy application that's got a lot of rule violations towards that ideal. Now, you may not get there, but this is the way to move towards that, or at least not make the problem any worse. Sir?
I assume it's smart enough that if you've got 5 failures in a class, you fix one of them.
Yeah. Correct. Yeah. The question was, is it smart enough to understand multiple failures in the same class and only remove one that you fix? It is smart enough to do that. And I use this because I work on an application that's 16 or 17 years old, and it has all sorts of violations for rules that I would like to enforce. And it's had, a couple hundred people work on this application because this is the application that makes my company money. So we use this to move our architecture gradually. Because again, it's hard sometimes to justify, well, I'd like to disassemble this whole thing to fix these 3 problems. As long as I can make it not any worse over time, I think that's great. So we've got these rules. How do I know that they're actually doing something, right? So who tests the tests? In this case, there's a couple of safety nets built in. If I say classes that reside in a package that doesn't exist should, and then some condition, if that list of classes is empty, this rule will fail. So if the predicate doesn't match anything, the rule will fail as a safety measure. Now, I can turn that off. One of the things that I do at work is I have a standard set of ArchUnit rules that lots of projects use. So I turn this off for those rules because not every rule applies to every project. So I can say allow empty should if you want that. But the empty should is a nice safety net. The other way you can do this, you can just test the rules yourself. Right? So we've got some ArchUnit rule. It doesn't even matter what the rule is or why we have it or anything. And then we've got some set of classes, right? Now, in our case, we're going to find it. We're going to write a class in our test area that definitely violates this rule. And then we'll run that rule. Remember at the beginning, I showed you the manual rule check. We'll run that. And since I use assert.j, I'll say assert that this lambda thrown by is the instance of assertion error and has a message starting with architecture violation. And you get more sophisticated. If you feel like that's not enough of a test, you can get more sophisticated with that. But that's a nice way to test that rule, intentionally create a class that violates the rule, and then make sure that that rule, when run against that one specific class, fails. So why use ArchUnit? You can quickly enforce architectural rules from within our project. All of these rules are in the project. We know why they're there. We have a good description of why they're there and what they're there for. It runs as part of the test cycle. It's completely inescapable that you would have some other system that would run it for you. This runs as part of your unit tests. They run really quickly. It documents the intent. I really like the because and the as because it shows me why I am doing this rather than just here's a rule, do it. I can put in there, why do I care about this? Why should you care about this as my coworker other than it's going to anger me if you don't follow it? Because it will. And it helps move legacy systems towards that those nice enforced standards. Again, it's hard to get a legacy system, which, legacy means making money for somebody. So it's hard to get to justify doing that. So this is a nice way to get those systems towards the light. So let's talk about integration testing. Has anybody ever seen this before? This testing pyramid? Okay, some people have, I'll explain it. This is the testing period. If you go to enough testing talks, you'll see this like every other time, right? And so at the bottom, you've got these more unit tests. You've got primarily unit tests in your project, and they run really fast, and they're really isolated from one another. And as you move up the pyramid, you've got tests that are highly coupled to your environment, and they're slower, and you generally have fewer of them. Now, this is held up as the ideal. And I don't know about you, but a lot of my projects end up looking like this because it's just such a pain in the neck to write integration tests sometimes. Sometimes they look like this. It's okay. Maybe we've got some integration, this manual integration tests, or again, maybe that developer was here for a little while and tried their best to come up with some integration tests and just, gave up. And everybody just annotated those tests with ignore and moved on with their lives. And so maybe we've got this, okay? And there's no shame in that. I've got this at some places, and there's no shame in this. But we can do better. So what makes this difficult? Why do we end up in this situation where integration testing is really difficult? Let's pretend we've got this application here. We've just got some application that talks to Postgres. This is pretty straightforward, okay? Not a lot of dependencies. We're relying on one thing. We're integrating with one thing. So why is that difficult? So how do we test it? Well, I can do an embedded database, right? I can run an embedded version of Postgres, and maybe for some implementations, this is fine. Maybe it does the same thing that I needed to do that the real version of Postgres uses. I'm not doing anything. That might work great. But maybe I'm not lucky enough. Maybe I don't use Postgres. Maybe I use something else. And so I'll use this stand-in H2 database. This is this in-memory database. I'll use this stand-in. And again, it's not going to be exactly like what I'm integrating with. Maybe I'll get lucky. Or maybe it's not even a database. Maybe it's something else that doesn't have an embedded version or is not easily embeddable. So, maybe I'll compromise. I'll run it on my own machine. Okay, so now I've got this problem. Now I've got to maintain Postgres. I've got to make sure that all of the authentication and all the security is the same. I've got to keep it up to date. I've got to make sure that the versions are the precise version that we're going to go into production with. And I've got to make sure that it's running and it's taking up memory and it's doing, all the things in the background that I don't really care to. I don't want to be a database administrator. So we'll use a central database. We'll have one database, and all of the developers will share this, and that's totally great until a bunch of randos on other teams come along and start using the central database. And then, one of them acquires a database lock on a table that I want to write to, and my tests don't work. Ask me how frustrating that is. I can tell you stories because I've been there. Or worse yet, we're all using this database. We've all agreed not to do any of the, holding table locks or whatever, but somebody switches versions. I'm switching a table to just play around with something. And now my application breaks because there's a missing column or there's a column that should be there that I don't know about. And it gets in my way or something like that. So what about a container? Maybe I just have a container on my machine that represents Postgres. This is the same kind of problem as running Postgres entirely, and now I've got to have a Docker container. It's easier because I can say, here's the blessed version of Postgres that we care about. It's set up correctly, and I just have to pull it down and run it. Now, this is getting really close to what we want. Problem is I've got to maintain that. I've got to make sure it's running when my tests run, and I've got to blow it away and re-download it or restart it every time I do a test run. Now that's better, but not ideal. What I really would like is if my application could have that same embedded thing where I could have the container I'm testing with in the context of my test. And so I don't have to maintain it. I don't have to worry about its life cycle. I can spin it up. I can use it. I can throw it away when I'm done. And that's what Testcontainers does. So how does it work? I'm going to give you a really simple version of what Docker does. This is grossly simplified. There's a Docker daemon or some kind of service running on your machine, and it's responsible for spinning up and destroying Docker containers, okay? And on top of that, there's a REST API. So when you have the CLI, the Docker CLI, you're talking to the REST API, and you're telling, hey, go pull this image down and start this container for me. Now, what if I can do that with my application? If the CLI can talk REST, my application can talk REST, and it can talk to the Docker REST API. Now that's great if I have a test that depends on an application. Testcontainers is also going to give me this other thing in the background. I'll mention it later. I just want you to know it's here. It's called RIOC. It's responsible for the life cycle of the containers that we will start. And I'll show you starting containers in a second. But I want you to just remember that RIOC is there because I'll mention it in a second. So what does Testcontainers need? It needs a Docker environment, kind of self-evident. It needs at least Java 8. Is everybody at least Java 8? Okay, heads nodding, cool. And you need either JUnit 4, JUnit 5, or Spock. And I'm going to show you examples using JUnit 5 because it's been out for like 5 years. So it's probably about time to move if you're still on 4. So when I said it needed a Docker environment, it can be a lot of different things. You could use Docker Desktop on your desktop. I run Rancher Desktop on my desktop, and I'll show you the examples I show you are running against Rancher Desktop. The trick with that is you have to use Dockerd instead of Containerd because Dockerd has the Docker API that we can use. And if these don't work, there's actually coming soon is the Atomic Jar, the Testcontainers Cloud. I haven't seen this. This is in private beta. So I haven't seen it, but it's this cloud-based version of Docker because, again, you're talking REST. You could do it on some remote machine. It doesn't have to be on your local machine. This is coming soon. It's supposed to be pretty cool. I've heard from people that they really like it, but I just haven't played with it yet. So adding it to our project is really simple. There's 2 dependencies in this case. There's Testcontainers itself, and there's the bridge to, in this case, JUnit Jupyter, which is Jupyter is the code word for JUnit 5. If you're a Mavenite, this is what they look like. Again, they're both in the test scope. It's the same two things I just showed you for Gradle. And let me show you an example. We've got a use case here where our Spring application, a Spring Boot application, is talking to a Redis database. Redis is just an in-memory, think of it as just an in-memory cache. It doesn't, we don't have to get too worked up about what Redis is. If you've never seen it, just think of it as a cache, okay? So let's look at this demo. Is this code, is that big enough? Should I make it bigger? Can everybody see in the back? Bigger? Good? A little bigger? Okay. How's that? Nodding. Great. Okay. So if you don't know Spring Boot, again, don't worry about the details too much here. I'll do my best to explain what is going on here. When you have a Spring Boot application and it talks to Redis, you use what's called, or you can use what's called a Redis template. In this case, I'm just setting up a Redis template that says, here's how to talk to Redis, and here's how to serialize and deserialize things from it. This is not the important or the fun part. And big in the font. So here's my test. It uses test containers. I annotate my test with this test containers annotation, and now that brings in the extension, the JUnit 5 extension for test containers, which does some work for me. And I annotate this container here. It's a static container. And I'll get into why it's static in a second. And I say, here's a generic container called Redis. And it's using this image here. So I'm saying, go pull down Redis 624 Alpine. And I want you to expose port 6379, which is the standard Redis port. When you start Redis without telling it to do anything, that's the port that it picks. And then in my test, I'm auto-wiring. We're using auto-wired because it's a test, and I'm not going to enforce the rules on that. and we say, here's the Redis template, that's great, and then we do something with Redis. And it doesn't, again, for the purposes of this, it doesn't really matter, it just matters that we have Redis available now. So we're saying, go increment a key in Redis by 1, and then just pull that back out and make sure that it works. Now, in reality, when you write these tests, you probably have some service that interacts with Redis, so you exercise that service rather than exercising the template directly. I'm just shortcutting a lot, so we don't have a lot of things to track here when we're running the test. So let's run this test, and it's going to fail. Hallmark of a great demo is having it fail. So you'll see these exceptions go by. When don't worry about those. And I think there was actually a version of Testcontainers that just came out the other day that I'm too chicken to update to because I got all these written before it was done. It was released. This is Ryuk, the gateway. Remember that I showed you that container, Ryuk. Its responsibility is for shutting down any containers that we define. So this Redis container, Ryuk's eventually going to shut that down for us. We don't have to worry about maintaining its lifecycle. But these exceptions here are just Ryuk trying to find a container that doesn't exist yet. So don't worry about those. So when we start our Spring application, we get this error saying we can't connect to localhost 6379. So why is that? Well, what happens when I say bind to this port? Testcontainers is going to pick some random port on my machine that is not being used and bind 6379 to that. That way I don't have these, if I have 2 tests running concurrently, I don't have to worry about both of them binding up 6379. I don't have to worry about testing order in that sense. And this is, I forgot to tell you why this was static. If this is static so that if I had more than one test in here, I would use the same container for all of those tests in this class. Otherwise, if I make it non-static, I'm going to get a new container for every single test. So to fix this, live templates to the rescue. This is just some Spring Boot code to say, here's a new set of properties that I want you to care about. And in this case, I'm saying, go get the Redis host and its first mapped port. I can interrogate this container to say, hey, what did you bind that 6379 to? And I'll show you, I logged it so we can see what it is because it changes every time. And so we'll run this failed test. And big in the font. And you'll see Riot complaining it can't find the container. And in this case, our test passes, as we expect. So let's look through this log. Now we've got a passing test. Let's look through the log for some fun things. Here's the fun fact that we board it. It's super fun, right? Port 50,189 is what it picked. That was some port that for some reason wasn't used on my machine at that time. And then the other part that's interesting here is this is starting the image, right? So I'm saying it checks that the Docker server is version at least 1.6, and then I've got this ungodly huge amount of memory dedicated for it. And it says I'm creating a container for this Redis Alpine, and then it's created, right? You're not pulling anything, it's not doing anything, because I already have that container on my machine, because I am too chicken, again, trying to demo for all of you and pull a container over conference Wi-Fi, because that's crazy. And I am not that brave. So I want to show you what this looks like. When you do pull the container, you'll get something like this. You'll see the layers being pulled. Now Redis, again, is really simple. And Redis is actually really fantastic if you need a cache. It's real small and it's real fast. And there's not that much to it. So I downloaded that at home in a second. Probably not even a second, it's just 10 megabytes, right? So it downloads the layer. Now if you get something more complicated with way more layers or other things, or sometimes these containers have more than one dependency, it'll take a little bit of time, but you only need to do that one time, okay? So now we've seen it in action. We know basically what's going on with a test container. So let's go back to that example I showed you before that we really wanted to do the Postgres. So we've got a Spring Boot test. We're auto-wiring some repository into here. And we want to write a test that exercises that repository. And we want to do it against a real Postgres database within a container. So again, I annotate my class with test containers. And I'll simplify. I'm not going to show you that boilerplate. We'll just simplify down to this. And I have my container. And I'll say it's a Postgres container. And I want you to go get me Postgres 14.2. And it'll pull all those layers and expose the default port. And I don't have to think about it because this is a specific Postgres container version rather than a generic container that I showed you before. And by using this, I get a few things for free. Again, if the same property, it won't connect for the same reason that it didn't connect to Redis before. I need to tell Spring Boot where to find it. I can do some things. I can set the database name if I want. I can set specific usernames and passwords if I want. That's all great. I can set connection timeouts and startup timeouts. I'm not going to go into super detail on this. I'm just showing you that it exists. And I can say, here's an init script. If I don't have Hibernate or whatever, creating the schema and filling it with data and whatever like that for me, I can say, here's an init script I would like you to run as soon as this container comes up and before you hand control back to me for my test. There's a lot of different database modules. I had not even heard of some of these. They're all supported, but one interesting one is this generic JDBC module. Now, there's a simpler way to do all these things I just showed you. This is a standard JDBC connection string, right? We've all seen these if you've connected to a JDBC database. If I add TC and a version number in there, the Java Service Loader is going to intercept this, and it's going to create a test container specific JDBC driver that's going to do all this work that I just showed you, and I don't have to think about it by just changing my driver. So what happens is the test containers JDBC driver gets created by my application, and it reaches out to Docker, and it says, hey, I would like you to start Postgres version 14.2 for me. And it says, great, I'll do that. And it makes up a username and a password and a database name and all that stuff. I don't have to think about it. I don't have to do anything. And then the last thing it does is it creates the version of the driver that would have gotten started, so Postgres JDBC driver. It creates that and proxies everything in my application through to that driver and then on to the container that it created. Now, I don't have to set any weird passwords. I don't have to do that dynamic property source because it's doing it for me. It's doing all the translating for me. So this is great. I just have to go through and say, here's your new connection string, and it gives you this database. I don't have to do anything. I don't have to set up anything. We can simplify this because Testcontainers knows what I'm doing. It knows what the database is called and where it is. I can leave off the name of the database, and I can leave off the host and port. So I can just do something simple like this. I can just say, I want a test container database with Postgres 14.2. If I want to initialize it, again, I can say here's an init script. It's on the class path. I can say here's a specific file somewhere with an init script. And here's an init function. If I have a class with an init function in it, I can have this do that. So if you want to run Flyway or Liquibase or whatever other manual stuff, you get a connection. You can do whatever you want with that connection if you want to initialize that. Sometimes you may need to, depending on how you have your Spring Boot app set up, you may have to manually specify that driver rather than letting the service loader do it for you. If I want to run stuff in more than one container, it gets a little bit of a pain in the neck, right? Because I have to do container setups for everything, and that's fine until I have more than one class that does the same thing. So you can move that up to an abstract base class. In this case, I have a Redis database and a Postgres database. I just define them both, and you'll see I'm starting them. I explicitly define the Postgres and start it, and then explicitly define Redis and start it. I have to do those manually in order to take over the life cycle. I'm not letting the JUnit 5 extension do that for me. And then I don't have to worry about this. That Raleigh daemon will go along and it'll say, hey, you started a Postgres and a Redis, and if after a couple of minutes of not using them, I'm just going to kill them off for you. So I don't have to worry about it. I don't have to think about it. I just start these and I'm off to the races. So anything that extends abstract base test will get these two things for free, and I don't have to. They'll get started for the life of all of those tests. So I don't have to worry about wasting time starting and stopping and starting and stopping for every test. If this is what you want, this is a nice simplification of it. I'll show you a quick demo on mock server. I'll make this quick. I realize that we're running out of time. Next window. And begin. Does anybody know what the Frinkiac is? The Frinkiac is the greatest site on the internet. It is an API that lets you put in Simpsons quotes, and it shows you scenes from where that happened in the Simpsons episode. I'm a huge Simpsons fan, so this is the best API on the planet. Exactly, you got the Ralph Prince demo reference. Thank you very much. He seemed like the kind of person that Martin Prince would do it. He seems like the kind of person that would do it. So I've got a simple service here. Don't worry too much if you don't follow this, if you're not a Spring developer or if I'm writing code that looks odd to you. Basically what's happening is I've got a search method here and I've got a string. I'm going to give it some string and it's going to reach out using a REST call to the Frinkiac service and it's going to get me some list of results. Now these results in Biggin are just ID and episode. It's completely useless, but go with it for the purpose of this demo. Now I'll write a test that uses those. So I'll say, here's my mock server. I don't want to reach out to the Frinkiac. I would like to test this on my own machine. Maybe I'm integrating with another team and they don't have their API ready yet. Or maybe I would like to put the API into failure modes that it's not easy to put it into. I work in financial services, so testing that things don't work the way I expect them to not work is important to me. So I use mock server to say, this system here that's authorizing transactions is going to fail in the way I want it to without me having to set up the more expensive simulator to actually make them fail that way. So this is why you'd use mock server. I have a mock server container. Again, dynamic properties, so I can tell Spring where the Frinkiac is, inject the Frinkiac service, and then I can run this. Now, I'm staying, arrange this standard result here. This isn't anything special, but this is how you integrate with mock server. You say, I am a mock client. I'm going to the mock server container we showed before. We're saying get the host and get the first map port. Again, it's going to be on some random port. And I'm saying whenever you get a request with the past API search, respond with just this dummy thing. And this is not useful content to respond with, but it's just going to give me 2 results back. So when we run this, I realize I'm almost out of time here. It'll pass. It'll go and create these containers. It'll run the test, and this will pass. Now, one thing that I really like is that I can inject failures now with this. If I start another container called ToxyProxy, anybody heard of ToxyProxy? It's pretty cool. It lets you, instead of talking to my mock server or my database or my Redis instance or my whatever, in whatever container, I am talking to ToxyProxy and it's talking to that container. So we put them both on the same Docker network and I define 2 containers, one for mock server and one for ToxyProxy, and I run my test. Now this test will pass. So I'm going off and I'm saying go search for Mr. Sparkle, which is like the funniest fake commercial that The Simpsons has, and make sure that there's 2 results. And again, we're mocking the results, so that's great. And we'll let that pass. But what I really would like to do is inject some failure in here. Does my application fail the way I want it to fail when the downstream service doesn't do what I want it to do? So we're going to say, hey, ToxyProxy, make sure that, of course, when I'm downloading things, I want you to limit the data to only 42 bytes. So ToxyProxy will let me do all the upstream requesting that I want, but when the service that I'm talking to, in this case mock server, responds with something, it's going to say, here, I'm going to cut it off at 42 bytes and close the connection. So we'll run this test, and this will fail because my service doesn't handle failure correctly. So this is great because now I can write tests that show me, it'll show me how to fail. Like I can inject failures into this and I can see, does my code handle this correctly? If I am responding with if somebody is responding with something and they close off early, do I handle that correctly? No. So now I'd go back and fix that. There are a lot of different modules that you can use here. I just want to highlight a couple before we finish. Azure, G-Cloud, LocalStack. LocalStack is an Amazon equivalent, so it's a mock for a lot of different parts of the Amazon stack. So if you're doing cloud-based things, you can mock parts of this, and again, you can wrap it around ToxyProxy and make sure that you fail correctly. You can put these into various different states. WebDriver, I had a demo in there, but because we're so close to running out of time, I can't show you, but I can use Selenium to say, here's a full UI test of my application. I can use that as you would use Selenium for any kind of UI tests, I can do the same thing with test containers. And then if instead of starting multiple test containers, if I did have a Docker Compose script, so Docker Compose is a way to say, here's a bill of materials for a set of containers, please go start them all. I could use that script in here and start a bunch of different containers with one call to test containers. So why use test containers? I'm getting isolated environments against real components, so I'm not doing an embedded Postgres, for example. I'm using a real actual Postgres that's actually going to be running in production. Even just a simple test of having the database come up, having my application come up and even just connect to the database is fantastic. That's practically the simplest thing you could write on this, and it would be a great improvement over not having any kind of integration tests at all. It's easier to test failure cases. Again, to me, testing that I'm failing correctly is important to me. I like this because it's easy to do that. I can run tests offline, so if I haven't pulled any images, I don't have the, or I guess I do, but if I didn't have my network connected, if I was on a plane and I was, felt inclined to work when I'm flying, I could do it. As long as I have those images pulled down, I don't need to be online to run these tests. I don't need to connect to any servers anywhere else. These all run without a network. And then the code and the integration tests are in the same PR and in the same repo. I don't have to have them in separate places, or maybe integration tests are maintained by a different group and they're in their own repo. I don't have to do any of that. They're in the same place, so we can see them in the same PR. So when people show you code, you can say, hey, well, where's the integration test for this? And I can't undersell this. Test containers is a fantastic way to smuggle new fun things into your project. Yeah, it's great because it's just a simple container. So playing with new things is much easier with test containers. So in conclusion, if you'd like ArchUnit, that's at archunit.org, and test containers is at testcontainers.org. Thank you for your time and attention. And stick around, Nihal's going to talk about patterns, right? Excellent.